So let's see, to solve this problem, this is from page 502. What we need to do is we need to identify what they gave us. I see they gave me a sample size of size 65. I know that the sample mean is that, and this is the sample standard deviation. So this tells me I have to use a t-distribution because I don't know the population standard deviation. So a couple of things we should do first off is I'm going to say that HO, the mean, I'll abbreviate U because I don't think I've got that math symbol here. So mu is equal to, is it different from 600? So is it the same as 600? And we're going to test that it's not equal to 600. Because it's different. The mean is different. They don't tell me a direction. That makes it a two-tailed test. All right, and the nice thing with the calculator, or applet, or whatever you want to do, I'm going to do this for the calculator because somebody asked. So 83s, 84s, they all work the same. So even though this is a TI-83. So we've got everything we need to evaluate this, and all I'm going to do to access this is press the stat button, and then arrow over to test, and because I've decided this is a t-test, this is test 2, and I've got statistics, I don't have data. So they're telling me what's the mean. Oops, I got to press the down arrow. The mean is 600, and this is why it's nice to set up your hypotheses first. Okay. Now the sample mean was 583.1, and the sample standard deviation. It's nice you notice that they tell us that is what is it? 114.9. And then we get the sample size, which is 65. So it's safe to use these techniques, even though we don't know what the parent population was like. We have a large enough sample size. And I have to make sure I highlight what my alternative hypothesis is, H1. At least I wrote H8, didn't I? But so the hypothesis we're testing is that it's not equal to, and you can either draw it or calculate it. I'll draw it just so we can see what that looks like. Except I've got another function being graphed. So there's that area. There's the t-score, the negative 1.8, right? And then we've got, there's a p-value, the 0.2401, which tells me that this is not statistically significant at the 10% level of the alpha equals 0.01. Okay? So because they told me I had to test at the 1% level, of the 10% level, and that p-value, which is the total of these two shaded areas, those two tails, and we had to double it because I said not equal to. It's a double two-tailed test. This tells me there isn't a statistically significant result. I can't reject HO. I guess there's no context to put this in, but we know we can't. The population mean is not different from 600. Okay, hope that helps.